You are live, sir. Please start your session.
I am Dr. D.K. Pratihar, Professor, Department of Mechanical Engineering, IIT Kharagpur. I welcome you all to second doubt clearing session of my NPTEL course on robotics. Now to start with, I'll concentrate on a few queries which have been put by the participants on the forum. Now, our TAs have already given a reply to those queries, but let me start once again with those queries. The first query which I got is as follows. If the area of triangle is scaling, then circle may not pass out three corners. So how can you create motion of robot path for obstacles? Now remember one thing, this bounding circle is an approximate circle which is drawn just to enclose that particular the triangular or rectangular or square or any odd shaped obstacle, the static obstacles. Now to draw the bounding circle for one obstacle which is triangular. So the triangles, all the sides could be equal, they could be unequal also or unequal also rather, and there could be a possibility that two sides are equal. Now we'll have to consider the bounding circle which could enclose all the possible triangles. Now for this scaling, this is a very special case where all the sides and the included angle are different, not equal. Now, in that case, the method which we can follow is as follows. Supposing that the three vertices of the triangle whose sides are unequal, so the vertices we are marking by the point 1, 2, and 3. And once you mark the vertices, we can find out the Euclidean distance between 1 and 2, then 2 and 3, then 3 and 1. So I'll be getting three different distance values. So out of these three different distance values, you consider the maximum one as the diameter of that hypothetical circle which I am going to draw. Now, out of these 1, 2, 2, 3, and 3, 1 distances, supposing that the 3, 1 is found to be the maximum. So, you draw one circle considering its diameter equal to the distance between 3 and 1, and the midpoint between 1 and 3 will be considered as the, the center of the circle. The circle which you could draw, that you consider as the bounding circle for the scaling. I hope I could clear your doubt. The next query, why are we considering that unusual point between YB and XB, which name is Q with respect to B? Now here the physical problem which we are going to tackle, let me explain once again. Now supposing that I'm standing inside one room near to the corner of this particular room. Now if you attach the world coordinate system to the corner of the room. It has got x coordinate, it has got x axis, y axis, and z axis, and my body has got another base coordinate system. And supposing that I want to do some manipulation task with the help of my fingers, with the help of my, say, right hand. Now my right hand has got some position and orientation information with respect to my body coordinate system. Now, if I want to represent the position and orientation of my hand with respect to the coordinate system attached to the corner of the room, then this is the method which has to be followed. Here, the coordinate system which is attached to the body is denoted by B, that is the body coordinate system, and the world coordinate system or the universal coordinate system which is attached to the corner of that particular room, that is denoted by XU, YU, and ZU. So I hope you have understood the physical meaning of this particular problem, and why do you go for this your the translation and rotation of a frame with respect to some world coordinate frame or the reference coordinate frame or the universal coordinate frame. So I hope this particular doubt is also made clear. The third one, here there is a doubt. In internet, it is mentioned that the father of robot is Joseph Engelberger, but you have mentioned in PPT the father of robot is George Devil. Now here to clarify, let me tell you that one is a robot and another is robotics. Okay, so the robot is the machine, the computer controlled automated machine or intelligent and autonomous machine which will be able to perform the task. And robotics is actually the science which deals with uh, the study related to design, development, and applications of robots. So let me repeat, there are two distinct terms. One is robot and another is your robotics. Now, if you see the history, the first robot that was developed in the year 1954, and that is done by George Devil. And accordingly, he is known as the father of robot, not robotics. On the other hand, the first robotics company to manufacture the robot might be in the commercial basis. That was done by Joseph Engelberger in the year 1956. And the first robotics company started by Joseph Engelberger is known as Unimation. And he is known as the father of robotics, not robot. And truly speaking, so one is the father of robot, another is father of robotics. So let me repeat once again. George Devil is known as father of robot. On the other hand, Joseph Engelberger is known as the father of robotics. So I think I could clear your doubt. The next is related to the hall tickets regarding the examination. So this particular problem, I think I'll not be able to make any comment, and this will be taken care of by our NPTEL office. So if you have any doubt, you can directly contact our NPTEL office regarding this date when you are planning to get the hall tickets. The next query, how are these two different velocity bound is NP hard and P space hard Could you please elaborate? Now, here, if you concentrate on this particular the PPT file, the one is motion planning among moving obstacles in 3D space without velocity bound, which is NP hard, and another is your motion planning among moving obstacle in 3D space with velocity bound is P space hard. Now, if you see the hardness, this hardness is measured with respect to the CPU time or the computational time of one, say, computer program. And this hardness, if you just compare, we take the help of like three terms. One is called the not polynomial hardness, another is called the polynomial hardness, and another is called the p space hardness. Now here the computational complexity which is measured, which can be measured in terms of CPU time, if it is found to be less, that is called the NP hard, that is non polynomial hard. And if it is computationally more expensive, that is called the polynomial hard. And if it is very complex, and if the computational complexity is very high, then it is called the p space hard. Now the moment we are considering the variable, so the velocity bound in consideration, the CPU time is going to increase. And that is why the motion planning among moving obstacle in 3D space with velocity bound is found to be p space hard. On the other hand, the same problem without any velocity bound is only np hard, that is non polynomial hard. So I hope you have understood the difference between the NP hardness, P hardness, and P space hardness. So these are the actually the queries which you got on the forum. And once again, I tried to give reply to your queries. Now we'll see if there is any other query which have been put once again in online. So is there anything in the chat box? Any comments? Any query? Can you please check if there is any such query in the chat box?
Sir, not till now.
Sir, till now we have not received.
Okay. So if there is no such query even in the chat box, so let me tell you, let me try to summarize like whatever has been taught during the last few weeks, might be the last 3 weeks of this NPTEL course on robotics. Now in robotics, like in my NPTEL course, I tried my level best to touch all four modules of robotics, namely the kinematics, dynamics, control scheme, and intelligence issues. Now, during the last 3 weeks, uh, I think you learned more about how to make the robot intelligent and autonomous. Now, before I give once again a brief summary, let me tell you that our aim is to develop the intelligent and autonomous robots. And truly speaking, there is a difference between the intelligent robot and autonomous robots. Now, we call a robot is intelligent when it can take the decision as the situation demands. On the other hand, if the robot is having the permission to act as an intelligent way, then only it is called the autonomous robots. And that is why I mentioned during my lecture class that all autonomous robot must be intelligent, but all intelligent robot may not be autonomous. Now, how to make the robot intelligent and autonomous? So, an intelligent and autonomous robot should be able to collect information from the environment. That is your, it should be able to collect information of the environment with the help of say some camera through image analysis, or with the help of a few sensor through multi-sensor data fusion. So, with the help of a camera, the robot collects information of the environment and then it is passed for carrying out the analysis, just to find out whether there is any such obstacle ahead of the robot or not. And this particular image processing, how to carry out, that we have discussed in this particular course in detail. That means your, we grab the image with the help of a camera, and then we try to represent that particular image on the say computer screen, and try to consider that this particular screen is divided into a large number of pixels. Then pixel wise light intensity values we try to find out, and corresponding to that particular image we'll be getting one matrix of light intensity values. And this matrix of light intensity values is going to represent the different object present in the environment. Now, the way we carry out the analysis, so as this particular matrix of light intensity values may have some imprecision, so we try to take the help of some pre-processing. So there are several methods of pre-processing like masking. Then we can use the neighborhood averaging. Then we can also consider some sort of the mean value, uh, and then or we can find out the median filtering we can use, and just to carry out this pre-processing to remove the noise present in the image. And once you've got that pre-processed image, we try to take the help of thresholding. And with the help of thresholding, we can find out the difference between the object and your the background. And once you've got that particular object, its boundary we try to represent with the help of some gradient operator. And once you've got that particular boundary information, then we take the help of one parameter that is called compactness, that is defined as perimeter square divided by area. Okay. So with the help of this compactness, we can identify the different objects present in that particular the scenario. Now, once you've got that particular information with the help of camera, and similarly, on the other hand, we can also collect information with the help of different types of sensors. There could be sensors for measuring the position, velocity, acceleration. There could be a few other sensors which will be able to help us to measure the force or the moment or the torques which is subjected to whenever the robot is going to perform some particular task. There could be a few other type of sensors like proximity sensor, range sensors and others, with the help of which the robot collect information of the environment. And once again, we have got the information of the environment. The next task is your make the motion planning, just to ensure the collision free path for the robot. And once you are able to find the collision free path through the motion planning, and if it is a multi-legged robot or the legged robot, we'll have to go for the gait planning also. So accordingly, we'll have to find out a suitable control algorithm so that the connected motor can generate the required force if it is a linear joint, or the required torque if it is a rotary joint, so that the robot can perform that particular the task. Okay. So all such things actually have been discussed in this particular this your the NPTEL course during the last 3 weeks. So this is actually a brief summary of this particular NPTEL course on robotics. Now I have got, I think, a few other queries online. Let me see what are the queries, online queries. The first online query which I've got, uh, please drop the message on YouTube regarding asking the question. Acha, if anyone is interested. Okay. This is, I think, posted by Vidapati, I think. Yes. The next is the next query which I've got. Uh, can we make a robot which have emotion? Yes, it is possible. So the emotion of a human being can be modeled using the tools like your AI tools, like say fuzzy reasoning based tools or neural network based tools. It could be trained also properly, and this particular expert system or the knowledge based system, which can represent the emotion of a human being, so can be injected to the head of a robot, so we can transfer so this particular artificially generated intelligence to the head of a robot. So it is possible the robot can be made emotional too. The next is your what is meant by dynamic performance of a robot. Now, this dynamic performance of a robot, like your if it is if the robot is having a few rotary joints, so we'll have to find out the necessary torque required. If it is having a few linear joint, the necessary force required. And once you've got the torque history or the force history in a particular cycle time, now this particular torque or the force ought to be generated within that particular cycle time in a very smooth way, so that there should not be any jerky movement of that particular the robot. Okay. Now, this dynamic performance is also related to whether this robotic joint is generating any undesired the force, couple movements, etc., which may generate actually some sort of vibration. And as I told, the movement of the different joints of the robot should be as smooth as possible. Now, related to this particular dynamic performance, in fact, the dynamic stability is also coming into the picture. Okay, so whenever a robot is actually navigating, uh, uh, we'll have to ensure that its dynamic balance has been maintained. Now, all the robots may not be kinematically balanced. For example, say if I take the help example of say humanoid robot. Now, this humanoid robot may not be kinematically stable. Okay, it cannot be statically stable also. So what you'll have to consider is its dynamic stability, dynamic balance has to be considered. And I hope I mentioned in the course while discussing a little bit on humanoid robot that a humanoid robot is actually has to be dynamically balanced even if it is standing at a particular the location. On the other hand, we have got a few robots like say four-legged robots, six-legged robots, eight-legged robots like the insect. They could be even statically valid. But truly speaking, whenever the robot is walking, the robot is navigating, its dynamic balance is more important. So we'll have to consider its dynamic balance. So by dynamic performance, we mean not only that the movement has to be smooth at the different joints, The drive unit which are put at the different joints should be able to provide the required force, the required torque as smoothly as possible. At the same time, the overall dynamic balance of this particular robot has to be maintained whenever it is navigating or whenever it is walking. So I think it is clear to all of you. The next is apart from CCD, which other vision device is used in robot vision? Now, there are a few other types of cameras also. I'll request our TA Pradeep Nahak. So he is also using different types of camera. So Pradeep, can you throw some light? What are the different types of other types of cameras which you are using now?
Yes, sir. We are using depth sensor cameras
Hmm.
for the depth capturing of any object in order to avoid the obstacles.
Yeah.
And and other cameras such as like your CCD camera is first priority
Hmm.
we are
Hmm.
using, and the
Hmm.
second camera is depth camera we are using,
Hmm.
and other cameras like GoPro cameras we are using. These are such
Okay.
cameras for the time being we are using.
Okay. Okay. Thank you, Pradeep. Now here, this stereo vision camera, that is the stereo camera, is very important because it will be able to determine the depth of the object also online. Okay, so it will have one extra added advantage if you use that type of your the stereo camera over the CCD. Okay, the next is your there was a question in the assignment. Masking is used in pre-processing for. Could you please explain that too? Okay, actually if you see the pre-processing of the image, the purpose I have already told. The purpose is actually to reduce the noise present in that particular your the picture. Now all of you know that whenever we are taking the snap of a particular environment with the help of camera, the quality of that particular image depends on a number of things. It depends on the angle at which I'm taking the snap, and it depends on the level of illumination, and of course it depends on actually the skill of that particular the cameraman. Okay, so there will be some imprecision and uncertainty, and to remove this imprecision we take the help of this masking operation. Now, this masking can be actually implemented in the computer program in different ways. For example, one could be the pre-processing can be implemented in different ways. One could be the masking with the help of one, like say they say 3 cross 3, some sort of template. Okay, and there could be another method that is called the neighborhood averaging method, or we also consider that is called the median filtering also to carry out this particular the pre-processing. And we have already discussed in detail how to use a mask or a template that is nothing but a 3 cross 3 matrix sort of thing of some numerical values. The sum of those numerical values will become equal to 0, and that is used as a template to carry out this pre-processing, and the purpose is to avoid the noise which is already present in that particular the picture. The next is your how will be the robotics exam on 21st of this month. Either it will acha, choose or question and answer. So if you just practice actually your assignment problem, that is your MCQ type, So here once again there will be MCQ time. So go on practicing your assignment problems. I hope you are not going to face much problem in your examination. The type of questions could be MCQ. Okay. So is there any question bank for this course? I'm sorry, I'll not be able to provide any question bank uh, which can help you in this particular the exam. My only suggestion is you listen to all the lectures and you practice all the assignments, and during the lecture whatever numerical examples and others which have been practiced you once again practice. I think you are not going to face much problem in the examination. uh, Please tell, is there any question bank uh, for this course to prepare for exam? Might be your assignment set of assignment problem, like 8 weeks each week, 10 assignment problems, okay, 10 MCQ. So you'll be getting this 80 MCQ. You practice, I hope you'll be getting a lot of actually help and assistance in the exam. Is next is MATLAB can be used to solve joint talk problem? Yes, MATLAB can also be used. Okay. The next is, please tell how to prepare for the exam. This I've already explained. The next is how the robot emotion and behavior connected to the scope of mechanical engineering concept and stuff. Now, as I told several times, that robotics has got four modules like kinematics, dynamics, control scheme, and your intelligence issues. So, these kinematics and dynamics are coming under the umbrella of mechanical engineering. Then, control scheme is coming under electrical and electronics engineering, and intelligence issues are coming under the purview of computer science. That means if one wants to be the true roboticist, he or she should have the fundamental knowledge of all the basic subjects. Okay, even being a mechanical engineer, so you can learn gradually. If you allow me to tell, I'm also basically a mechanical engineer, but to meet the requirements to carry out research in the field of robotics and artificial intelligence. So I also learned many things related to like robot intelligence, control little bit. So these are the fundamental things which you'll have to learn. Okay. Which next is which important software language is popularly used to control the motion of the robot? Now you see uh, there are a few programming language we have for the different types of robots, and the manufacturer of a robot select or develop that particular programming language which will be compatible to the compiler used. Okay, because using the compiler, the computer program which you are going to use to control the movement of the robot, its machine language file or the .exe file has to be generated. Now this compiler is going to help to compile the program so that it can create the .exe file before it is passed to the microprocessor. So this is the way actually the robots are controlled. Okay. Now this programming language, it could be of different types, and its compatible compiler has to be used. So if the robot is going to use a language, a particular language might be it is very similar to say C programming or the basic programming, so its compatible compiler has to be connected to the robot, then only it will be able to generate that .exe file which could be used in the microprocessor of that particular the robot. So I hope you have understood any programming language with the appropriate compiler can be used. Okay, which camera would be suitable to track image in different medium, considering the camera is in air medium and the target is in water, specifically to detect if anything cross out of the border. Now you see, this camera, this camera are generally used along with the robot in air medium. Okay. Now, whenever you are going to collect information, say underwater for the underwater robot, so generally we'll have to be dependent on different types of sensors. For example, we can go for some sort of range sensor like your the sonar sensor and others. With the help of sensors, we'll have to collect information of that underwater atmosphere. So, preferably, like the camera is used in air medium, and in underwater atmosphere, we generally go for different types of your the sensors. The next is if we practice the assignment problem, uh, we can get the same question in exam. The same question you may not get, so might be you'll be getting similar type, or could be a few different types of questions only. But if you practice the assignment problem, and if you listen to all the lectures, and if you understand, and if you practice the numerical example, I don't think that you people are going to face too much problem in the exam. Okay, but you may not get exactly the same question which have been put, all the questions which have been put in the assignment. Okay, when will we get the hall ticket? Hall ticket information, like I think our NPTEL office will be able to provide when they are going to distribute the hall ticket. My suggestion is you be in touch with NPTEL, or use look into their website at regular interval. So you'll be getting the time or the date from which they are going to issue the hall tickets. Okay, so please look into the website of our NPTEL at regular interval to get the information. Okay, the next is your sir, could you explain in detail how can sonar sensor be used continuously to detect if anything crosses or leaves the border or the marked area? Now, you see, whenever we are going to use any sensor, so what we do is we always consider some sort of period during which we are going to collect that particular information. Okay, so the sonar sensor send some sound, it will be reflected and it will be captured. Okay, so it requires some time step or some amount of time. Are you getting my point? Now, to find out the difference, like if something is passing or this thing, like if that particular speed is too much, like if something is passing with a very high speed, we may miss that particular the difference. Okay, but if it is moving with some medium speed or a reasonable speed, then there could be a possibility that we'll be able to detect the difference in your the reflected sound, and that will help us to determine how much is the distance between the robot and your or the sensor and that particular the obstacle. Okay, and by doing that, you can find out the approximate information. So now, if you want to find out the difference, then definitely the speed, the range of the speed is actually one of the criteria. As I mentioned, if some obstacle is moving with very high speed, so we may miss it. We may miss the information. Acha. The next is your which robotic application will be mass produced or be used in near future. Nowadays, you see, the robots are used just to replace the human being from some hazardous place, or if there is some task which are repetitive in nature which human operator may not like, so there we are going to replace the human operator by the robot. And all of you know nowadays a large number of robots are used in different industries to automate the different operations. For example, say it can do some sort of material handling task, it can do some sort of assembly task, it can do some inspection, repair type of job, it can also do some sort of painting type of task. So different types of tasks can be given to the robot in your the industry. Similarly, nowadays there are many applications of the robots in medical science. I've already discussed about telesurgery. Then comes your different types of robots developed in the form of capsule or the tablet, which will be able to detect if there is any possible location of tumor or that type of thing inside the body. Okay, there could be the application of robots just like your the nurse in the hospital, and nowadays, you know, even in our space time, there are many such applications where the astronauts are going to be replaced by the robonauts. Similarly, there are different types of applications where human operator can be replaced by the suitable robot. Acha. Uh, Next is I would like to explore a real-time project model based on which we discuss the content. So how can you interact with your system? Now, if you have some specific problem uh, which you want a solution with the help of a robot, so you can discuss with me. You can send a mail to me. I think you people know my email address also. That is dkpra at mec.iitkgp.ac.in. So you can send a mail, but generally I get many mails per day. So might be I'll be little bit late to give you the reply, but I'll try to give you the reply. We can discuss on this, and in NPTEL there is another provision for the NPTEL intern. Okay, so if you can become the topper or one of the toppers, so in this particular course, then there is a possibility you'll be getting this NPTEL internship. I think that internship could be 1 month or 2 months, something like that, and you will be getting some little amount of money also as internship. So actual amount I do not know, but you'll be getting some internship money also. Okay, there is another possibility like that. Another scheme has been started, that is 1 year internship program. Some of the students they are working with me. Uh, they're working on different types of robots like wall climbing robot, pipe climbing robot, and those people, those students have come for 1 complete year. Okay, and NPTEL has started this novel scheme where this intern student will be getting some fellowship also. I think might be around 25,000 per month or something they'll be getting for 1 year. Okay, and they can work with me at IIT Kharagpur. So these are the opportunities which you have. Next is your Sir, on which topic we focus? You can focus on design development of different types of robot, and if you want to design and develop a particular type of robot, the first thing is you'll have to identify the task. Okay, and if you can identify a suitable task, and to perform the task we can think of designing and developing new types of robots. For example, we also develop different types of robots, different depending on the various tasks. The next is your uh, huh, what is the procedure or methodology to develop an object picking? Just a minute. Object picking and collecting objects from a floor, just a simple project. What else knowledge I require apart from this course uh, for that project? See, whatever has been taught in this particular course, that will be sufficient if you want to solve a simple task like pick and place type of operation. So, if the robot is going to pick some object and going to place it at another object, so this type of pick and place type of operation can be handled very efficiently with the knowledge which you have gained through this particular the course. The next is what path one needs to follow to develop such simple mini project. This I have already told. You identify one or two tasks, and to tackle that particular task, to solve that particular problem, we can spend time on thinking a new robot, a suitable robot, and then we can go for its design analysis. If required, we can modify it, then we can fabricate, and we can control it, we can make it intelligent. Uh, for example, say now we are developing the pipe climbing robot and wall climbing robot, and those are in their development stage. Uh, Next is your uh, is there job opportunity in future? Yes, because you'll find not only in our country in India, like in abroad also, uh, uh, there is a lot of requirement in the field of robotics and artificial intelligence. Okay, and if you allow me to tell you, related to artificial intelligence, we have got, I have developed some other NPTEL course like physiological neural networks, which will be rerunning in the coming semester also for the seventh time or sixth time or seventh time. You can take it. You'll be getting the fundamentals of AI tools also. And this particular robotics, then artificial intelligence, there will be huge requirement throughout the world. So you'll be getting a very good job opportunity in the areas like AI and robotics. Next is which country where robotics research is rapidly increasing. You see, if you see the history, you'll understand the lot of robotics activities have been carried out in US universities, then in Japan, Japanese universities, and you'll be getting some European universities also like Germany, France, UK, and in our country, India also, there is a lot of work going on in the field of robotics and artificial intelligence. What is the eligibility for 1 year course? Now, this 1 year internship, if I can correctly remember, the eligibility is your BTech degree. The minimum requirement is your BTech degree in mechanical engineering, computer science, or electrical electronics. Okay, And if you have the master degree, that will be an advantageous. But the minimum degree which is required is your BTech in mechanical, BTech in electrical, or in electronics, or in computer science. Nowadays, robotics and AI goes hand in hand. That means an engineer, just a minute, and engineer, uh, huh, that means an engineer we need to be familiar with. Yes, nowadays robotics and AI. In fact, we work in both the areas, and we are working since 96. I'm working since 96 in this particular the area, 1996. I've written the textbooks. Also, you can have a look on robotics, on AI. Separate textbooks I have written. uh, Recently, their current editions have been published also. Uh, Next is, could you name a few companies where we could gain experience via internship in the field of robotics? Now, in the field of robotics, even in India, we have got a few startup companies. Okay, so these companies are uh, Noida based. There are a few companies at Pune. uh, and there are a few companies in Bangalore also. Okay, so these startup companies in robotics where you can do the internship, or uh, the research labs of different IITs, ISC Bangalore, and NITs. You can find out a lot of work is going on. For example, even in at our IIT Kharagpur, we have got a Center for Excellence in Robotics, which has been started by me, a lab now. It is a robotics lab, and so a lot of work we carry out in the field of robotics and artificial intelligence. Ha. The next is your yes. I have made robot of which uh, can separate magnet materials, and yes, you can use that type of sensors. There are a few sensors which will work only for the magnetic material. There are a few sensors which will be working both for magnetic as well as non-magnetic. Now, if you use that type of sensor which will work for the magnetic materials only, like say Hall effect sensor, or if we use some sort of inductive sensor, those sensors will be working only for the magnetic material. So by using the Hall effect sensor or inductive sensor, you can find out the difference between the magnetic material and non-magnetic material. I think that's all. Is there any other query? I think that's all.
No, sir.
Okay, okay. So if there is no other query, then I wish you all the best, all the best for your examination and all the best for your future. I hope all of you enjoyed this particular course and have learned a lot. I wish I wish you all the best once again. Thank you very much. Can I disconnect? Can you come out of the meeting now?
Yes, sir.
Hello.
Yes, sir. You can, sir.
Okay.